Imagine you're at like 30,000 feet.
Okay.
Alarms are just absolutely blaring inside the cockpit. The digital screens in front of you are flashing amber, red, just indicating this massive cascade of mechanical failures.
Right. Total sensory overload.
Exactly. And every single human instinct in your body is screaming at you to just grab the radio, hit the transmit button, and yell for help so someone on the ground can clear the airspace.
Oh, absolutely.
But the aerospace company that built your airplane has this cardinal rule for this exact moment. And the rule is do not touch that radio.
Which is wild, right? It defies basic human nature. And that's exactly why it has to be explicitly taught and just, ruthlessly trained.
Yeah, because your brain just wants help.
Exactly. The instinct to reach out for a lifeline when we're overwhelmed is so deeply ingrained in our psychology. But in modern aviation, yielding to that instinct before you secure the physical reality of the aircraft well, that's often the first step toward an unrecoverable disaster.
And that tension, right, that tension between human instinct and machine logic is exactly what we're unpacking in today's deep dive.
This is a fascinating dynamic.
It really is. So we've got our hands on this really incredible internal presentation from Airbus.
Yeah, from 2012, right?
Yep, dated June 12th, 2012. And it's titled APPI. That stands for Aircraft Procedures, Pilots, Interactions.
Right.
And our mission today for you, the listener, is to explore how one of the largest aerospace manufacturers in the world manages the squishy, completely unpredictable human brains sitting inside their highly advanced aircraft.
Squishy is definitely the right word for it.
Seriously. And if you've ever felt completely overwhelmed by a new piece of software at your job, or maybe felt like a computer system was just doing things without your permission.
Oh, we've all been there.
Yeah, then the philosophy in this document is going to resonate deeply with you. So, okay, let's unpack this. Because to really grasp why this internal presentation even exists, we have to understand the massive technological shift in how modern airplanes are actually flown.
It's a huge paradigm shift.
Right. The document notes that this safety philosophy is built for the entire Airbus fly-by-wire family, ranging from the A320 all the way up to that massive double-decker A380.
Yeah, the really big ones.
So I understand that means computers are heavily involved, but how does fly-by-wire actually fundamentally alter the human being's job in that cockpit?
Well, okay, so think about a traditional older aircraft. The pilot's control stick is mechanically connected to the actual flight control surfaces.
Like with physical cables.
Exactly. Physical steel cables, pulleys, hydraulics that move the elevators on the tail. When you pull back on the yoke, you literally feel the aerodynamic resistance in your own hands. You are directly operating a physical machine.
Okay, so it's like driving a really heavy old car without power steering.
That's a great analogy.
Yeah.
But in a fly-by-wire aircraft, that direct mechanical connection is completely severed.
Wait, severed? Like it's not connected at all?
Not mechanically, no. When you pull back on the control stick now, you're simply sending an electronic signal to a central flight control computer.
Wow.
Yeah, and that computer evaluates your request. It factors in the current speed, the altitude, the aerodynamic limits, and then it sends its own digital signal to move the tail.
That is wild.
Right. You are no longer flying the plane directly.
Yeah.
You are effectively voting on what the plane should do.
Voting. That is a crazy way to put it. So the pilot transitions from being a physical driver to essentially like managing a supercomputer's interface.
You're managing a digital interface, yeah.
Yeah.
And if we connect this to the bigger picture, Airbus doesn't just build planes anymore. They build interfaces for humans.
Huh.
And because that underlying digital architecture is standardized, the core philosophy of how a human interacts with it can just be scaled across the entire global fleet.
Oh, I see. So the APPI concept applies everywhere.
Exactly. A pilot can transition from a short-haul regional jet to a massive long-haul airliner without having to completely rewire their mental model of how to interact with the computers.
Because the software logic is the same.
Right. The physical aircraft changes, but the human-machine interface remains consistent.
Okay, that makes a lot of sense. And the APPI presentation breaks this operational reality down into sort of three-legged stool for safety.
Yes, the three pillars.
Right. Before diving into the specific rules pilots memorize, it states that the safety and efficiency of any flight depends on three distinct pillars. First is the aircraft design itself.
The hardware.
Right. Second is the procedure design. And the third is proper operation by crews following a set of golden rules.
And that third one is the kicker, because the first two pillars are entirely static.
Right. The engineers design the plane, and the regulators write the rules.
Exactly. They meticulously design the hardware and the software limitations. The regulatory bodies establish the procedures and traffic rules. Those elements do not change once you are up in the air.
They're set in stone.
Right. But the third pillar is the dynamic wild card, the human operator.
The squishy brain.
Exactly. And that is precisely why the acronym APPI ends with the word interactions.
Aircraft, procedures, pilots, interactions.
You got it. The hardware and the published rules are basically useless if the pilot interacts with them poorly under the extreme stress of an emergency.
It's totally like driving on a busy highway. You have the engineering of the car itself, right? That's the aircraft design.
Right.
And you have the traffic laws and the painted lanes. That's the procedure design.
Sure.
But if the person behind the wheel is like looking at their phone or just completely distracted, the whole system fails. The human is the final failsafe.
That's a perfect way to look at it.
Which brings us to the anchor for that third pillar, the golden rules themselves. The presentation outlines 4 of them, and they're stamped across this training graphic like a quick reference guide for survival.
They're very direct.
They really are.
Yeah.
But here's where it gets really interesting. I want to challenge the very first rule.
Oh, really? Okay.
Yeah, because it states, quote, fly, navigate, and communicate in this order and with appropriate task sharing.
Yep, the golden trio.
And to make sure nobody misses the point, the slide actually repeats the first part 3 times. It says, fly the aircraft, fly the aircraft, fly the aircraft.
They really hammer that home.
They do. But I brought this up briefly at the start, and I just have to push back on this strict sequence.
Okay, lay it on me.
If my engines fail, or, God forbid, a fire breaks out, my absolute first instinct is to declare an emergency over the radio. I mean, I want air traffic control to move other planes out of my way and get fire trucks to a runway. Why is Airbus demanding the pilots actively ignore the radio?
Okay, so you have to consider the extreme cognitive load placed on the human brain during a catastrophic, unexpected failure.
It's got to be overwhelming.
It's completely overwhelming. Human working memory is severely limited. Under a sudden spike of adrenaline, our perceptual field literally narrows.
Like tunnel vision.
Exactly, visual tunnel vision.
Yeah.
And we also experience auditory exclusion, where our brain just starts processing certain sounds so it can focus on a perceived threat.
Wow, so you literally might not hear alarms.
Or you fixate on the wrong thing. So if a pilot diverts their limited cognitive resources to picking up a microphone, selecting the correct emergency frequency, and trying to explain this complex cascade of failures to someone hundreds of miles away.
They aren't flying the plane.
Exactly. They are no longer dedicating their brain power to the pitch and airspeed of a 150-ton machine that is currently falling through the sky.
Okay, so you are effectively taking your hands off the steering wheel to make a phone call while skidding on black ice.
Yes. The ground controller cannot fly the plane for you.
Right.
The radio will not keep the airplane in the air. Communication is entirely useless if you lose aerodynamic control and stall the aircraft.
Because then you're just crashing while talking.
Exactly. So the rule forces the crew into a state of strict psychological triage. The immediate existential threat to life is the physical trajectory of the aircraft.
So step 1, fly.
Right. Once you stabilize that, you ensure the wings are level, the nose is at the correct angle, the speed is safe, then you move to step 2, navigate.
Figuring out where you are.
You figure out your geographic position so you don't steer a perfectly stable airplane into the side of a mountain.
Okay, that makes sense.
And only after the physical trajectory and the geographic path are secure do you actually have the surplus mental bandwidth to communicate with the outside world.
Man, it's just a mechanism to force discipline over panic. Like, fly the aircraft, fly the aircraft, fly the aircraft just becomes this mandatory mantra to break the human instinct to ask for help before helping yourself.
Precisely.
And the presentation explicitly ties this survival triage to what they call appropriate task sharing.
Right, the cockpit roles.
Yeah, it divides the cockpit into 2 distinct roles. There's the PF, which stands for pilot flying, and the PNF, the pilot not flying.
Very literal name.
Very literal. And the document aggressively warns, quote, don't allow anything to distract you from your role as PF or PNF.
They do love their exclamation points in these slides.
You really do. Now, the pilot flying role makes intuitive sense, right? You are the one currently managing the trajectory. But I want to zero in on this pilot not flying role.
Yeah.
Because pilot not flying sounds completely passive. It sounds like you're just the backup driver staring out the window until it's your turn.
That is a very common misconception. But the presentation demands the exact opposite of passivity.
Really?
Oh yeah, it defines the pilot not flying role as an intensely active state of vigilance. The text specifically dictates that the PNF must actively monitor the flight parameters and highlight any excessive deviations.
Okay, I did notice the presentation puts the words actively monitor in all capital letters.
Yes, to heavily emphasize the point.
I see the capitalization, but why push the word actively so hard? Like,
Hmm.
shouldn't a highly trained professional pilot naturally pay attention to the flight instruments, even if they aren't the one touching the stick?
Well, you would think so, but human brains are notoriously bad at monitoring automated or delegated tasks.
Really? Why is that?
When you are not the individual physically executing an action, your brain naturally relaxes. We subconsciously assume the person or the computer currently in charge has the situation handled.
Oh, like when you're in the passenger seat of a car, you aren't really watching the road the same way.
Exactly. Think of it like trying to proofread a document you just wrote yourself. If you read it normally from start to finish, your brain will frequently autocorrect the typos.
Oh, I hate that. You just see what you meant to write.
Right, your brain knows what the sentence is supposed to say, so it completely ignores the visual reality on the page. Professional proofreaders often use a technique where they read the document backward, word by word.
Oh, to bypass the brain's autocorrect?
Exactly. It forces them to actively evaluate each individual element out of context.
That makes perfect sense. So the pilot not flying has to adopt that exact same unnatural forced vigilance.
Yes.
They aren't watching the flight to admire the clouds. They are actively hunting for deviations. They are the built-in human alarm
The
system.
human redundancy?
Right. So if the pilot flying becomes totally task saturated during an emergency and fails to notice they're dropping altitude too fast, the pilot not flying is the circuit breaker that has to verbally intervene before the flight control computers register a critical failure.
Spot on. And that dynamic leads directly into the central friction of modern aviation.
Which is what?
Well, once the crew has triaged the emergency and stabilized the physical aircraft, they run into the next major cognitive hurdle in a highly computerized cockpit. Who is actually flying the airplane? The human being or the digital interface?
Right. Which brings us to golden rule number 2. And this is where the balance between human psychology and complex engineering gets, like, really delicate.
You really do.
Rule number 2 states, quote, use the appropriate level of automation at all times.
It sounds so simple.
It does. And the presentation clarifies that this appropriate level depends entirely on the specific situation and the task at hand.
The wording there is key because it requires the pilot to constantly evaluate the machine's performance rather than just turning it on and, forgetting about it.
Like following a GPS blindly. Sometimes the GPS is the safest route, and sometimes it literally tries to drive you into a lake.
Exactly. You have to monitor it.
But what I find incredibly profound is the explicit permission Airbus gives the pilots right after that sentence. They actually write out pilot judgment prevails, including selecting manual flight.
What's fascinating here is how huge of a statement that is.
Right. For anyone who interacts with advanced technology, that is a massive philosophical stance. I mean, we are talking about billion-dollar supercomputers programmed by thousands of engineers to execute flight plans with mathematical perfection.
Yep.
And the manufacturer is explicitly telling the human operator, hey, if you think the computer's wrong, turn it off. Take the stick. Fly it yourself.
Because Airbus is aggressively combating a psychological phenomenon known as automation bias.
Automation bias, what's that?
As machines become more reliable and sophisticated, human beings develop an intense over-reliance on them.
Okay, I can see that.
If an incredibly advanced flight computer indicates that the aircraft is maintaining a safe altitude, but the pilot looks out the windshield and sees the terrain approaching rapidly, human intuition suggests the pilot would instantly pull up to avoid the ground.
Obviously. You trust your own eyes over a screen, right?
You'd think so.
Hmm.
Yet accident investigations across aviation, medicine, and industrial engineering consistently reveal that humans experience severe cognitive dissonance in those exact moments.
Really? They don't just pull up.
No, they actually begin to doubt their own physical senses. They assume they must be misinterpreting the visual data because the billion-dollar machine couldn't possibly be making a mistake.
Oh my God, that is terrifying.
They freeze. They wait for the computer to recognize and fix a problem that the computer does not know exists. So by explicitly codifying pilot judgment prevails into a golden rule, Airbus is attempting to short-circuit that deadly hesitation. They are providing the psychological authorization for the human to overrule the machine instantly.
It's incredibly empowering, but man, it also places a massive cognitive burden on the human being.
It absolutely does.
You are overriding millions of dollars of engineering because your human judgment says so. But to make that judgment call, to accurately recognize when the automation is no longer appropriate, you have to be absolutely certain you know what the automation is currently trying to accomplish.
Exactly. You cannot actively monitor a system, nor can you safely override it if you do not fundamentally understand what the system is currently thinking.
Which perfectly transitions us to the final two golden rules, and these operate entirely as a paired mechanism, right?
Yes, they go hand in hand.
Let's look at golden rule number 3. Understand the FMA at all times. Now, I have to admit, when I first read through these sources, I just stared at this acronym for a while.
It's not super obvious if you aren't a pilot.
Yeah, the text we're looking at doesn't actually spell out what FMA stands for. It simply demands that pilots understand it. I was genuinely confused. So, what exactly is an FMA? And why is understanding it so critical that it warrants its own dedicated golden rule alongside fly the aircraft?
Right. So FMA stands for Flight Mode Annunciator.
Flight Mode Annunciator, got it.
It is a critical visual display located at the very top of the pilot's primary flight screens. In a fly-by-wire aircraft, because you are managing a computer interface rather than pulling physical cables, you must constantly know what specific mode that computer is currently operating in.
What do you mean by mode?
Well, is the computer actively holding a specific altitude? Is it following a pre-programmed GPS route? Is it managing the engine thrust to maintain a specific airspeed? Or has it switched to prioritizing a steep angle of climb?
Oh, I see. So the FMA is essentially the airplane's internal monologue made visible.
That's a brilliant way to put it, yes.
It's the computer explicitly telling the human what it thinks it is supposed to be doing at that exact second.
It is the ultimate expectation setter for the crew. If you do not understand what the FMA is communicating, you have completely lost the narrative of the flight.
You're just guessing.
Exactly. You cannot actively monitor a complex system if you do not know what the system is attempting to achieve. Without that knowledge, you are reduced to a passive passenger, simply waiting to see what the machine decides to do next.
And if you become a passive passenger, you completely violate the previous requirement to be the pilot not flying who actively hunts for deviations.
Right. It all unravels.
Which perfectly triggers the fourth and final golden rule: take action if things do not go as expected.
Yes. This is the critical mechanism that links the entire philosophy together into a closed loop.
So what does this all mean in practice?
It is the ultimate safeguard against complacency.
It creates a continuous feedback loop of human awareness, really.
Exactly.
Because Rule 3 dictates that you understand the FMA, which means you have a firm expectation of what the plane is about to do.
You know the plan.
Right. And then Rule 4 dictates that if the physical reality of the plane does something else, there is a dangerous disconnect between your human expectation and the machine's reality.
And you don't just sit back.
No. You don't wait to see if the computer figures it out. You don't succumb to automation bias and doubt yourself. You take action. You intervene.
And taking action loops you right back to the very beginning of the entire philosophy.
Oh, wow, it does.
Think about it. What action do you take? If things do not go as expected, Rule 2 states your pilot judgment prevails.
So you select a different level of automation.
Or you disconnect the computers entirely to take manual control, which means you are immediately back to Rule 1. Fly the aircraft, then navigate, then communicate.
It is a brilliantly engineered psychological loop. This APPI presentation strips away all the hyper-technical engineering jargon when it matters most.
It really distills it down.
It takes the incredibly overwhelming environment of a cockpit flying near the speed of sound at 30,000 feet, relying on millions of lines of digital code, and it distills human survival down to 4 constant behaviors.
It's elegant in its simplicity.
It is. Manage your panic by flying the physical machine first and talking later. Don't let the computers intimidate you into passivity. Constantly read the machine's mind so you know what it wants to do. And the exact second reality stops matching your expectations. Intervene immediately.
And because this specific behavioral loop is standardized across the entire Airbus fly-by-wire family, it builds a deeply resilient organizational culture.
Because the humans are the same.
Exactly. The physical hardware will change, the software will continue to evolve and become infinitely more complex, but human cognitive limits, our working memory, our tendency to panic, our vulnerability to automation bias, those remain exactly the same.
Yeah, we're still just squishy brains.
Right. These golden rules succeed because they acknowledge and mitigate those human limitations rather than pretending the advanced technology has somehow just, eliminated them.
It's a sobering reminder that we haven't engineered the human element out of the equation. We've just shifted where the human needs to apply their focus.
Absolutely.
And while these guidelines were written for professional aviators making life or death decisions in the sky, it is really impossible to ignore how this underlying psychology applies to so much of what we do on the ground.
Oh, for sure. We live in an era where we are constantly interacting with complex systems that automate parts of our daily lives.
Yeah.
We share tasks in high-stress corporate environments, and we frequently defer to software algorithms to manage our workflows.
Which brings me to a final provocative thought I really want to leave you, the listener, with today. Think back to that specific instruction for the pilot not flying. The explicit mandate to not just sit there, but to actively monitor this situation.
Like the proofreader.
Exactly. Much like a proofreader, forcing their brain to look for errors rather than letting the mind auto-correct them.
It takes effort.
It takes a lot of effort. So, in your own life, when you are in the passenger seat, when you are the pilot, not flying in a major collaborative project at work, or during a chaotic family event, or even just relying on a new piece of technology to manage your finances, are you passively going along for the ride, assuming the system or the other people have it all figured out?
It's so easy to do.
It is. Or are you actively monitoring the parameters, fully engaged and ready to take decisive action before minor deviation becomes an unrecoverable disaster? It's something to seriously consider the next time you find yourself blindly trusting the machine.